3x plus 2y is less than or equal to negative 2, and x plus 2y is less than or equal to 2. So I need to rewrite both of these in y equals mx plus b. I know they're both going to be solid lines because they both say less than or equal to. First thing I'm going to do is subtract 3x from both sides. And I'm going to have 2y is less than or equal to negative 3x minus 2. I'm going to divide by 2. Y is less than or equal to negative 3 halves x minus 1. And I'm going to graph that the same way I would graph y equals negative 3 halves x minus 1. I'm going to do the same thing for this equation. I'm going to subtract x from both sides, or this inequality, I mean. 2y is less than or equal to negative x plus 2. Divide by 2. And I'm going to have y is less than or equal to negative 1 half x plus 1. And I would graph that the same way I graph y equals negative 1 half x plus 1. So I'm going to start at the negative 1, and I'm going to go up 3 and over 2 throughout my graph. Break out my ruler. And I'm going to draw a solid line. Zero, 0 is not located on that line, so I'm going to plug it in. Is 0 less than or equal to negative 3 halves times 0 minus 1? Is 0 less than or equal to negative 1? No, it's not, so I shade the region of the graph that does not contain 0, 0. So that would be everything on this side of my line. I'm going to graph my second equation. I'm going to start at the positive 1, and I'm going to go down 1 over 2 throughout my graph. I'll break out my ruler. Solid line. 0, 0 is not located on my line, so I'm going to plug it in. Is 0 less than or equal to negative 1 half times 0 plus 1? Is 0 less than or equal to 1? Yes, that's a true statement. So I shade the region of the graph that contains 0, 0. So that would be located everything below my line. So everything that gets shaded in twice is considered a solution to the inequality, or system of inequalities.